I'm going to give a update here of the positioning, how this is going. Last time I made a video about this, again, I'm doing this for a degree that I'm working on as the capstone project, and I'm building a system for use in autonomous robots and other things where positions can be estimated just from vision without needing GPS and things like that. So where I had left, so part of what I've built is an app that will help me visualize what's going on, so that I can tell how accurate it is, and just to make it more useful. So the basic test I've been doing, repeating as I iteratively improve this is my basement here. The dots are landmarks. So these are locations where I've kind of imagined this XY coordinate. That's my basement, and this being the origin 00. And so my map, it's just a JSON file that tells, it just text basically saying at coordinate 86108 you will find an object that is a light or other things like that, repeated for all the different landmarks. So then the cameras on the robot look around, see what's around, and then using properties of the camera and the image and everything else kind of triangulate a position and a heading. So the test that I've been doing, that I keep repeating to be able to tell if I'm improving things or not, is I will set the robot over here at the axis and to the left a little bit, so like -50, -75, 0, and I will have it determine its position and kind of push it in an N shape. And what I'm trying to do is kind of check out how accurate it is over here, how accurate it is towards the middle, and how accurate it is over here. And there's probably other better patterns I could do, but this is an easy one that I can do over and over and over. And I'm trying to make this N shape. And as you can tell, this was 11/9, so this was about 2.5 weeks ago. Sometimes it was okay, sometimes it's way off. So it actually, all in all, was pretty terrible. So that's where I was a couple weeks ago. I've made a lot of improvements since then. Another thing that I was running into is, so this is the same session, the heading. So what it's doing is figuring out what is my position and which direction am I facing, with 0 being up or north or whatever you want to call it. And sometimes, so then south or down would be 180 or -180. So the highest absolute value measurement you should ever have is 180. And I would get these weird 274, sometimes -300 something. Those are obviously problems. So I had to work on those. So some of the changes that I've made, because I probably spent 80 to 100 hours on it since this test was done, trying to think of anything to improve it. So I've got a list here of some of the things I've done. The servo angles, I had already gone through a round of using a protractor to mark points on the camera mounts, and I thought I had that worked out, but so the camera mounts being these things that rotate down here. So I put little markings on them and then visually checked and adjusted that code's on an Arduino that controls what it is sending to the servo versus what angle it thinks it's pointing at, things like that. So I had adjusted that. One thing I did not account for when I did that, I don't know what that video is. There's a picture. Okay, so what I have these mounted to, these 3D printed mounts that my wife made for me, I don't know if I have screws tightened. Well, it's something about either the shape of the back of this camera. I think that's what it is. But when I tighten them to the mounts, it kind of contorts the camera a little bit, and it's actually, even though it looks like it's facing directly ahead, it's facing off to the right just a little. So what I did was I set up this laser protractor thing. I don't know what the name of this tool is. And I would take photos, have the robot take photos and then I would look at where it thought it was pointed and kind of use this to put up little sticky notes on the wall at different angles, and use that in combination with the photos I was getting back to tell, what the angles actually were. And I also double checked the field of view, because I'm using a Pi camera, version 2 on one robot, and a Pi camera version 3. And I do crop the photos that are coming back before I feed them into the model. So it was very possible that my field of view degrees I could have calculated that wrong. So I used rechecked that, and that was all okay. Yeah, so I had already mentioned in the previous video that the light system works really well, because my object detection models, the TensorFlow models, have been trained to identify these lights, an individual light. So if I ran that model on this picture right here, it would hopefully see 3, 7, 10, 13 lights. And so that's what I get back from the model, the location of these lights and the sizes, the bounding boxes around them. And I wrote a layer of code that will take that and then convert that into landmarks by checking it looks for patterns. So my code will identify if there's a triangle, a vertical line, a square, and even if the bounding boxes are a little off, which happens a lot from those TensorFlow models, I'm only looking at the center. So if it said this light is, this big, and this light's tiny, the centers would still line up. So I'm actually able to get really good landmark sizes, and I can use the height in combination with the field of view to estimate how far they are away. I'm also on my map using non-lights, such as, I just saw a picture, yeah, so these things, this house. But here's a good example here. See how big it's the model's telling me this house is, so it's overestimated it. So distance wise, I would be guessing that I'm closer to that house than what I actually am. So these are okay, they're better than nothing. And the angle on them, knowing that this is near the center of the image and knowing what direction the camera is facing, I still get a lot of information out of here. It's just the estimating distance from this picture is not the best. So the lights are definitely preferred if they're there. And on that note, I did add one thing I added that made a big change was I have 2 tiers on my map, which I probably have on a browser here. I've got a browser right in front of me. I do have, I've added on my maps a tiering system. So everything that shows up on the map, so this is actually a windmill, not the light, but I've got different tiers, which I can name these anything, but I've got a mid tier, a high tier, and a low tier, and then a priority. So when my code is looking at these objects and deciding what's a landmark and what's not, and then deciding which ones to pay attention to and which ones to ignore, it kind of sorts them by tier and priority. So the ones that are likely going to help it get a better view of where it's at, those kind of get bumped up to the top. And if there are some lower ranking ones, but I can see enough of everything else, I kind of let the lower ranking ones fall away. So that the LIDAR, so I did find out, because sometimes my angles were off, partly because of the camera being distorted a little bit, and partly because sometimes I just had some orientations, vehicle versus landmark orientations I had not accounted for quite right. Sometimes the angle, the heading was off, and the angle that the system thinks the vehicle is heading, the angle of landmarks relative to the front of the vehicle have to be pretty accurate for me to know which LIDAR measurements to pull to try and improve a visual distance measurement. If that's off by just a few degrees, I'm going to be pulling a LIDAR measurement off of a wall or something else, and then the coordinates get way off. It's almost better as if I don't use the LIDAR in that case. And actually with the lights, the distance is pretty accurate without the LIDAR. The LIDAR sometimes improves it by a few inches, sometimes it doesn't, and on a scale of 900 inches. So the LIDAR does help with some of the other, like the windmill, some of the other smaller objects that the bounding boxes tend to be off on. So yeah, this was a biggie too. There was an issue because the LIDAR device is hooked up to an Arduino, which I probably have a photo of that here. Well, you can't see it there, but there are two Arduinos back there. Here we go. That this LIDAR device is feeding into this Arduino Duo that's got a lot of memory. So it's constantly running, constantly feeding its measurements to this over a serial connection, and I'm looking at every quarter of a degree, so it's about 1,400 different values I'm storing in an array. And anytime the Pi or the Nano wants to pull LIDAR, I just let it. I could probably do this better, but I have it pull the entire 360 degrees from the last few seconds. And so that's 1,400 measurements coming across strings. Again, I could probably do that better, but it's a lot of bytes passing through a serial connection between the Arduino and the Linux computer in a short time, and the serial buffer was getting full, and I was losing half the LIDAR measurements in that transition. So I fixed that. That made a big difference, because I was really only getting a LIDAR picture of a third to a half of the room before I noticed that was a problem. Yeah, so another thing I noticed that was kind of a big deal, this was that the model for the lights, let's see. Yeah, so the square light, these light patterns are great, and they really help it estimate distance really well. The lights are very easy for the TensorFlow models to identify. Very easy, especially if you've got the lights off and it's dark. But something about the frame on this square was making it not see some of these lights. So it took me a while to figure that out, but if I cover the frame with any kind of fabric like this, then the TensorFlow model will give me back all four lights. So that made a big difference. Yeah, so I did a lot of testing, making sure I was getting that back. So with all those done, I'm going to repeat my end test, and there were more changes than that. I've just already been talking for 15 minutes, and yeah, so I will rerun my end test. The preliminary tests looked pretty good, but I've only been sticking it in one place here and there and turning it around. So we'll see how this goes. Okay, so I went through that test, making the pattern in my basement, and it definitely looked really good. I could tell. So as I'm pushing the stuff, pushing the car. Also, you noticed I'm using the car instead of the. I had been using that observer vehicle, so I've switched to the car since that's actually what I'm going to be actually trying to do useful things with. So as I'm pushing it around, I can see on the back of it, if you see me like squat down and look back there, the display is showing me where it thinks it is and the heading and stuff like that. The coordinate, determining the coordinates and all that logic, it does take a little bit of time right now. I'm not too worried about that because if I want to, I could optimize that and make it a lot faster. Equipment's getting faster too. So I'm really just trying to make sure that this is feasible and with inexpensive equipment right now. That's what I'm trying to do that anybody could get. And again, I know that the car may look like a little much, like there's a lot going on there, but the goal here is to try and make something that's inexpensive and can be attached to any car or anything else and be able to make use of this logic without spending too much money and without being huge. So I think I'll end up with a lot smaller of a device that does all this. And also this car, it has its own Wi-Fi hotspot. It's running a Postgres database. It's running a REST service, doing all kinds of stuff that this wouldn't have to do for someone else. I need it for my testing and for things like that. So anyway, it did look really good. The quick view here, that is very good. It was a little off here, but these numbers are inches, so I would say that was like maybe 20 inches off. But compared with what I was looking at before, this was the second test, which was an improvement off of the first test, which was this stuff. So we're doing a lot better. Also, the headings, I was watching those closely as I did this. These were all quite good. I didn't get out my protractor, but I would say these are within a couple of degrees. And I think that what I've got now is good enough that I can start doing some actual application off of it. So what I want to do is use this to do something a little more interesting. So for a start, I've got my if you saw the first video I did run through a driving test, and that was when when the positioning was like this. So the car went a little crazy. So I'm going to repeat some of that. Within the app, I can do things. This is how I do this. I built all this functionality into the app and everything else before the positioning actually was working. So I kind of got ahead of myself. But I can tell it to go somewhere. I can tell it to search for things. I can shut it down. Tell it to log its LIDAR. I can switch maps. If I've got different versions of this map, of this basement, one of them may be oriented north to south, one may be oriented west to east. It doesn't care. I can switch that right here and give it a new command. I can give it a bunch of them. I actually made it where I can tell it search an area for something, and it will divide that assignment up into lots of them and queue them up for multiple robots. I'm not quite ready to test that yet, but so I'm going to run through some tests, having it look for objects, point them out. This actually X's will show up here at places where it estimates something is. So if I hide a, I don't know, if I hide that house over here, or I hide something else it knows how to find back here where it's not visible from the starting point, it should be able to travel over there, find it, and then it'll have to run some calculations to estimate the position based on where the vehicle thinks it's sitting. Those calculations I've made them all, and they worked for some small tests I did, but there'll definitely be some kinks to work out there. But I want to be able to hide some things around the basement and tell the robot, just find these and tell me where they are, and it figure out what search pattern it's going to use, and be able to mark them on the map. And what I think would be really neat, and I don't know if I'm going to have time in the near future, but I think I will. I've got these laser things off of Amazon, these laser modules, and I think it would be neat to have those mounted to the car and be able to tell it, go find something, like go find this stuffed animal, and take a picture of it, put the laser on it, take a picture of that, tell me where it was, things like that. And then even further than that, multiple cars coordinating to cover a whole area and do that type of thing. I would like to do that, so I'm a little ways from that. We'll see how that goes. So it's definitely some good progress for now.